For this example, we're looking again on the interval from 0 to 2. And in this situation, that means we're really only looking at this part of the graph. And just a side note, if we were looking from -2 to +2, if you notice, during that entire interval, if we look on the interval from -2 to +2, the upper curve is the quadratic 2x squared over the entire interval, and the lower curve is the quartic, or the fourth degree, x to the fourth minus 2x squared. So even if we were looking at this interval of -2 to +2, we could still accomplish this either with one integration expression with limits -2 to +2, or with one expression using symmetry. So just kind of an aside there, but that is just related to the problem at hand. It's not exactly what we're looking for, but we don't need to do what we did in the last example. So for this one, on the interval of 0 to 2, we're just looking at this green shaded area again. And in that case, as I mentioned before, this is the upper function, there's the lower function. And so when we set up that integral, we're looking at the upper function being 2x squared. And then we're going to subtract the lower function here. And the lower function is x to the fourth minus 2x squared dx. And then the lower limit would be 0, and the upper limit would be 2. And so looking at that expression then, again, this is easy enough to integrate. We end up just using the power rule to integrate all of this. And so integrating 2x squared becomes 2/3 x cubed. And integrating x to the fourth is going to be 1/5 x to the fifth. And this is a minus a negative, so it's going to be plus. And integrating 2x squared again, we get 2/3 x cubed. And then we can go ahead and evaluate that from 0 to 2. And if we go ahead and plug that in and evaluate that from 0 to 2, we'll get the answer in terms of a fraction. But at this point, I want to remind you that we can also use our integration technique on our TI-84. And so if we go into math and we look at our integration ability here, we can do fint, and then we can go ahead and put in our expression. In this case, our expression is this whole expression here that we have in the integral expression. So we've got 2x squared minus x to the fourth power plus 2x squared. And we're going to, the variable of integration is x, and the lower limit is 0, and the upper limit is 2. And so we have our expression that we have in our integral. We have our variable, our lower and our upper limit, and we hit the enter key, and we end up with an answer of 4.26 repeating square units. And if we want to know what that is as a fraction, we can go ahead and get that as a fraction by hitting the math button and then selecting 1 for fraction and hitting enter. And that is 64/15. which is what you get if you'd integrate and combine all the fractions with a common denominator. For this example, it involves a little bit of trigonometry here. We've got a sine function and a cosine function. We're looking at minus pi over 2. So if we look at minus pi over 2, that is this location here. So we're looking at a region from minus pi over 2 to pi over 6, which are the two regions where the functions intersect. And so we're looking at this green region here. And so if we look at that region, we see that the blue function, which is a cosine function, is the upper function or the greater function throughout that entire region. So we do not need to have two integrals. We can get away with just one integral. The lower function is sine of x. So setting up the integral for this, we have the integral from minus pi over 2 to pi over 6. And we're going to have cosine of 2x minus sine of 2x, or sine of x, dx. And again, you should be able to integrate this by hand. Cosine of 2x would be another u sub, where we let u equal 2x, and our du then expression, our differential expression, would be 2 dx. So for the appropriate substitution then, we would say that half a du would be substituted in for a dx. So looking at that u sub then, the expression for the upper function becomes, instead of cosine of 2x, becomes cosine of u times 1/2 du. And if we put in the limits of integration here, when x equals minus pi over 2, then when x equals minus pi over 2, then u equals minus pi. And when x equals pi over 6, u equals pi over 3. So the new limits of integration become minus pi to pi over 3 for that expression. And then subtracting then the other expression, minus pi over 2 to pi over 6 of sine of x dx. And we could go on and integrate this all out. But again, I think we're going to reinforce that the TI graphing calculator would be advantageous at this point. And we're going to go ahead and write this expression in our fint again. So on our TI-84, if we go to math and we pick option 9, fint, and we go ahead and write this expression. So we have cosine, and actually before I go any further, I'm going to clear everything out, because the first thing I notice is that we have radian mode here that we need to be in. And I noticed that we need to be in radian mode because of the limits of integration, which are in radians. So coming back to our TI-84, I'm going to check our mode, and sure enough, we're not in radian mode. So I'm going to go ahead and put us in radian mode so that the calculator is evaluating the appropriate limits of integration. And then go ahead to math 9, get our fint, and then I can type in cosine of 2x minus sine of x, and variable of integration is x. The limit, the lower limit is minus, that's our opposite sign here, pi divided by 2, and our upper limit is pi divided by 6. And when I evaluate that, the answer then is, after I integrate that, the answer is 1.299. And as you might expect, this is an irrational number. And the reason why I say you might expect that is because you know that exact values for radian expressions involve expressions like pi over 3 and pi over 6 involve things like square roots of 2 and square roots of 3. So we can't just use the fraction function in our calculator to get an exact value. But I do know that when you do integrate this by hand, this ends up being 3 times the square root of 3 all over 4. And that is the exact value. Notice when I answer this, I keep it to 3 decimal places, which is in accordance to the criteria set by College Board. So a decimal answer would be 1.299, and an exact answer would be 3 root 3 divided by 4.